Hi, in this video I'm going to show you if you have multiple cables going towards the same direction, how to identify which cable is yours using the cable tracing device. Here, if you can see, I have two cables running right across from one end to another. This can work with 5 cables, 6 cables, how many ever. The reason they're plugged in is because I don't have soil here to earth them, but you could also just earth them on both ends. As you can see, one is earthed here, one is earthed here. And similarly, on the other end, both are earthed here as well. Now, in order to check which cable is ours, let's say I want to check for the black cable, not for the blue cable. I'm going to first use this device, which is the transmitter. I've set this to 3.2 kilohertz. I can set this to any frequency from 197, 640, 1.28, 2.56 or 3.2 kilohertz. I'm going to choose 3.2 kilohertz here. Now I'm going to take this clamp and I'm going to attach it onto the cable I want to identify, which is the black cable. Remember that this arrow should be pointing in the direction you want to transmit the signal, because I'm going to want to measure it over there. So I have connected it over here in this direction. Remember that both cables need to be earthed. Now it's set to 3.2 kilohertz. It's detected coupling mode because I've used a clamp. Remember, you can use Crocodile clips as well, which is even better. I'll show that in a later video. But here I've used the clamp method, and now I'm going to click on start. When I click on start, you can hear a prominent hissing sound, which tells you that frequency is passing through the cable. Now I'm going to use the transmitter. When I attach this CD to the transmitter like so, it automatically goes into cable identification mode. Now what I have to do is I have to open the CD and I have to attach it at least 2 meters away from where the signal is being transmitted. And remember, the direction of this arrow should be in the same direction as the transmitting signal. Now it is going in that direction as the arrow indicates. I come back to this device and I click I will long press it, and it is calibrated now, showing as the target cable. This calibration is important so as to identify when we know which part is the known section of the cable, because we know that this is the cable we want to identify. We need this in order to calibrate so that we can further ahead in an unknown section identify between the right cable and the wrong cable. But you need to do this calibration, otherwise it can give you a false positive or a false negative reading. Make sure that the frequency indicated here, 3.2 kilohertz, is the same as the one on the transmitter, because the receiver and the transmitter should have the same frequency. Now I'm going to test it on the other end, where I don't know hypothetically which cable is which. Let's say there were 5 or 10 cables of the same type. I wouldn't know which cable is which one. Here it's blue and black, so it's easier to identify. So I'm going to now attach the CD here, which is far away from the original. It can be up to 10 kilometers away. As you can see, I have attached the CD to the black cable. It is facing the direction that the current is flowing in. It is coming from there towards here, so the arrow is facing in that direction. And as you can see, it shows as target cable. This green value, the phase is what it expects it to be, and the percentage is close to 100. These are the two factors it uses to identify whether it's a target cable or not. Now, since this is an area where I don't know which one's which, I'm going to attach it to the blue cable. Now that I've attached it to the blue cable, You can see it's in the same direction. I don't know whether it's the right or wrong one. You can see the device rightly shows as non-target cable. And just to test it again, if I remove it from here and I attach it back here, again facing in the direction, you can see it shows as target cable. Now I'm gonna test it with the Crocodile clips when I have access to the conductor itself. I'm gonna use the red Crocodile clip and I'm gonna attach it to the conductor like so. And then I'm gonna take the black Crocodile clip and I'm gonna attach it to the earth like so. As you can see, the black Crocodile clip is attached to the earth and the red Crocodile clip to the cable I want to identify. Now, since I want to do a new round of testing for cables, I'm going to have to delete the previous calibrated data. So I'm going to click on I. I'm going to have to long press and it shows me whether I want to delete the marked data. I'm going to click up and I'm going to select yes. Now I will take this CT again to calibrate. Again, it should have to be around 2 meters away from this so that it prevents interference. I'm gonna attach the CT here. Again, it should face the direction in which I am injecting the current. This again is a location that I know that this is the cable. This is just the calibration part. That is not the cable. I know this at this location. I'm gonna actually check for the cable further ahead. Now I will start the current again. Now this is at 32.7 kilohertz. It has to be the same as here. So I'm gonna change this to 3.2 kilohertz. As you can see, this is 3.2 kilohertz now. And now this is also 3.2 kilohertz. Now I will start injecting the current. The CD is ready in the spot. And now I'm going to click out. Now, calibration is done. It knows that this is the target cable. Now I'm actually going to go to the site where I'm confused about which cable is which, and I'm going to test it out. Now I'm on the site where I'm not sure which one is my cable. I have calibrated it there and I'm injecting from that side. Now I'm going to check on both cables to identify which cable is mine. So I'm going to take my CT and I'm going to attach it around one of these cables. Remember, the arrow has to be in the direction of which the current is flowing, and as you see here, it identifies it as the target cable. Now I'm going to test on the other one. Like so. Again, same direction as the current is flowing, and it shows me as not the target cable. Even if the percentage matches, sometimes the phase angle will differ by a lot, which helps you determine whether it's the target cable or not. These two, not usually needed, but this is what tells you whether it's the correct cable or the incorrect cable that you're trying to identify. Now remember, here there are only 2 cables, so it's a little easier for a demo video. But if there were 10 or 20 cables that look exactly the same, you're going to have to test on each and every one of them until you know for sure which cable is yours. This helps you not having to cut, or even in a single core cable like the blue one, you don't need to loop around and check for continuity. You just need to make sure both sides are earthed, and then you can do a calibration on the end you're transmitting from, and then you can test on an unknown section. Remember, calibration always needs to be done on an area where you know for sure which cable is yours.